Hello, good evening, everyone. Welcome to the internal assessment series. So, from today onwards, maybe from for the next week, I would like to give a brief orientation by using some problems, the real life problems on internal assessment, on how to do an internal assessment, where to get ideas, okay, what to look for, how to arrive at the final problem. I'm not actually giving you the full IA, but I'm just giving you about a brief outlook of okay how to solve this. Okay, so without wasting my time, let me just start doing this. Let me share my. Okay, so now let us begin with this. So internal assessment. So planning your internal assessment, what is that you are going to do? That's what we are going to look into it. So we're going to look into the step by step through your physics IA. So first thing is, let us define a question. Okay, so I'm not giving you the strands behind it. Okay, so look into the physics guide, understand about it and so on. Okay, I'm directly venturing into the problem and I'm discussing with the problem and along with it looking at the strands. Okay, so a practical approach. So let us start with a very simple question on something like defining an RQ. The first RQ that we define here is, how does the variable affect the acceleration of the moving object? Okay, very simple thing. Many of us can ask these kinds of questions. So while we put across an RQ, what is it we need? We need two things over here. First is we should have a variable here. We should have something which is very defined over here, which is acceleration. And in what context? The context here is very brief moving object. Okay. Now, do you think it is complete? It's completely incomplete. Okay. Why is it incomplete? Reason is because moving object can be anything, right? It can be moving in a straight line. It can be moving along an incline. It can be moving along a circle. It can be moving along a parabola. It can be anything, right? So therefore, it's still an incomplete one. Then acceleration. Which acceleration? Are you talking about a one-dimensional acceleration? That's not clear. Okay, let us keep this for time being. Okay, anything when we start with, okay, so it will be incomplete, and later on as we proceed further, okay, we can what you call refine it and finally get a proper answer. Okay, now let us consider this as our preliminary RQ. Later on we need to refine it. Now think about the variables. What are the variables? We can do it over here. So we have to change something. What is that we need to change? This variable. I do not know what is that variable. We'll look into it. And we need to measure something. What is that we need to measure? We need to measure the acceleration. And what is that we are going to control? Still not clear, right? So therefore, what we understand from this statement is only about what we can measure over here. We are going to measure the acceleration. That's what is so far clear to us. Okay, initially we started with nothing. Okay, we'll go step by step. We'll understand what is that we are going to do, and later on we'll start refining one by one. Right, let me go on to the next slide. Now when we go for this, so we have several ideas. What are those ideas? The first idea that we have is that starting idea is mass of the object. Can we vary the mass of the object? We have a variable here. So let us read the question once again. How does the mass affect the acceleration of a moving object? Would this be right? Of course, okay, when you increase the mass, acceleration may change or will change, right? Because we know from here that A is equal to F by M. So therefore, if M increases, the value of A should decrease over here. Okay, something which we know. Materials affecting heat conduction. Can we use this? No, we cannot use it, right? Okay, so because heat conduction is not something which we can use. So therefore, this is an incorrect question we can ask, right? So usually, how do we get this question? We get this question, okay, most of us nowadays currently what we do is we take this one, put it across in chat GPT and finally get this, right? So here also we do the same thing. Okay, so therefore we have got one such idea here. Materials affecting heat conduction is completely incorrect. So therefore we can outline it directly. Okay, then applied force magnitude. When I increase the force, what will happen? Acceleration will increase. So therefore I can now say acceleration will increase when force increases. So this is a sensible question. This is also a sensible question. Then applied force magnitude. Oh my God, I've got the same thing over here. Okay, so anyway, this is not required. Okay, by copying, pasting, I did a mistake. Okay, maybe wantedly also I would have done it. Let me go to the next one. Next one is length of the incline. Okay, so now I'm talking about an incline suddenly. Okay, so what happened initially? I consider an object like this. It was like this, and you applied a force over here, and as a result of it, it was moving. Or maybe you stacked one object after the other. As a result of it, mass of this increased, so acceleration changed. Okay, these are two things we already seen. Now what we have done is we want to change this. Okay, we have not considered this to be a plane object, but we have considered this as an incline over here. And in this incline, I'm going to drop it here, or maybe I'm going to drop it here, or maybe I'm going to drop it here. I'm going to increase the length of the incline. This can also be one of the variable. Okay, so fine, let me consider this. Then starting at this one is initial velocity. Maybe instead of just dropping it over there, I can give a small push over here, right? So when I give a push, definitely the acceleration may change. So this could also be one of them. Okay, and then type of the surface material. Maybe if I use a wood, metal, carpet will be very slow here, no? Okay, the object will not even move over here. So this could also be. I have 6 different ideas. Okay, so of which of them would be considered, which of them may not be considered. Okay, let me go back. Not even 6. Okay, these 2 are completely ignored because it's the same one here, and this cannot be considered. Mass of the object can be considered. Acceleration depends on it. Then this will also be considered because A is equal to F by M. For a given value of M, and the value of F increases, value of A will also increase. The acceleration. So this is also considered. Okay. Now let me consider here length of the incline. I do not know. Okay. If the length of the incline increases, does the acceleration increase? Because it has to move a longer distance, no? So will it increase? That has to be understood only by some understanding of the physics behind it. I cannot say anything about it. Let me put a question mark here. And then what about the initial velocity? When the initial velocity is larger, what will happen to the final velocity? The final velocity when it reaches here will also become larger in the same amount of time. So as a result of it, definitely you can say acceleration is defined by v minus u divided by t. So it depends upon the initial velocity. Acceleration will also change as a result of this. Your final velocity will change. So hence this might probably change. Type of the surface material, definitely. But see, this I do not know. This is okay. This one also, it is not clear to me. Because you know, when you measure something, see here, length of the incline, you measure it using your meter scale. Initial velocity, you measure it using your meter per second. The previous slide, you see, mass of the object, measure it using kg. Then applied force magnitude, you measure it using Newton. Okay, but if you consider this one, I do not know by what measure do you put it across. Okay, wood has a density. Then what else you have? Wood has a structure. Wood has a mass. Okay, can we use any one of them? No. What is this which is playing a role here? Friction plays a role over here, right? Friction. The friction on each of these surfaces with the object is now changing, and as a result of it, you think, okay, things might change, right? Okay, so therefore friction plays a role. So you should get what is the friction you need. So be narrowed over here. You should get the value of mu over here. If you get the value of mu, you can easily start with it. Now this value of mu has to be measured. You cannot directly do it, right? You take a wooden piece, okay, get a wooden for example, and you ask what is the mu of that wood? Can we get it? You will not get it. Can we get a mu for a metal? No, you cannot get it. Because mu depends upon not only on the material, it also depends upon the object that is placed on it, right? Mu is a coefficient of friction which depends upon the interacting surfaces. So therefore, definitely you cannot determine, okay, using this. So as a result of it, I will just consider this not to be a feasible one. Okay, now you see, we have introduced a new constraint over here, feasibility also. Okay, now out of which how much we have? We have length of the incline, initial velocity, mass and force. Okay, see, we started with one statement. We've got 4 ideas now. Okay, we can do 4 ideas, 4 ideas over here. I can give it to all my friends and say, okay, hey, I will take this one, you can take that one, and so on, right? Okay, let me see further, okay, how this can be useful. Now, the next question I have is that, see, this one, anyway, I have 4 variables over here. Acceleration. Now, how do you measure the acceleration? Do we have an accelerometer in our lab? We don't have something called as an accelerometer. So what is that we have in our vehicle? In our vehicle, in our scooter, in our bike, we have something like an object moves, okay, and there is something which is detecting. What is that? This is called as a odometer. What does your odometer do? It measures the speed of a vehicle, okay, it doesn't measure velocity. How do you measure acceleration? So this is a big question. We don't have an accelerometer. See, the variable that you have put over here should always be a measurable variable. So if you cannot measure, then don't put that variable over there. So therefore, I feel that you cannot measure acceleration using this. So what is that I should do? Okay, or can I measure acceleration? We can always say, if I can calculate acceleration, why can't I measure? So how do you calculate acceleration? You can calculate acceleration by using a equal to v minus u divided by t. This is one equation you can use. The other equation we use is, you can use s equal to ut plus half at squared. You can use this also. You can calculate the value of A from here. If the time of fall is known to you, okay, I take an inclined plane, I take an object, drop it there, and as it starts falling down, if I know what is the value of the length of the plane is given here, the time taken, I use a timer and I can find out what is the time, or I can find out the acceleration. What are you doing over here? Are you measuring? You are not measuring. You are only calculating. You are only calculating. So when you say you are calculating something, that cannot be a dependent variable. A dependent variable is something which you need to measure using a meter, using a scale, something you need to measure, right? So therefore, definitely this cannot be considered as a variable. Okay. Now I don't want to change anything over here. First, let us understand. Okay. So how do you continue with this one here? I don't want to change the RQ. Don't change the RQ immediately. I want to continue with the same RQ. But what is that you can do here? So if I cannot use acceleration, what is that I can measure here? I can measure the time. Can I use time as a variable? Definitely you can use time. Can I use length as a variable? I can use length as also a variable. But now let us see what are the methods to find out the acceleration or calculate the acceleration. Okay, so still I have something in mind saying that I am going to calculate the acceleration. Okay, and how does the acceleration depend upon the variable that I have chosen? And the variable that I have chosen is mass, angle theta, the length of the plane L, incline. This is an inclined plane, mass over here, length of the plane L. What's the other variable? Force applied over here. Now this appears to be very simple. Okay, I will not have anything to reflect on. I'm not going to use this one. Again, force, as you know, it's very difficult to measure. You should have a spring balance to measure this force, and sometimes I might make a mistake, and it's very simple, I feel. Okay, there could be some anomalies there. I'm not going to use this also. Now I have to change only on L and theta, right? Now let me further go and see. Out of 4 ideas, I have now truncated, I have removed 2 more ideas, and I have only left out with only 2 ideas. Okay, now let me move on further. Now how do we define acceleration? You can define acceleration using a method known as a ticker time apparatus. I don't know whether you have this in your lab, but you can try it out in the old physics labs. You can definitely find this. It's something like you have a roll of tape, and then you have something like a machine wherein there's an electromagnet which is being connected to this. This could be connected to an AC supply or maybe an eliminator, and so this generates a constant frequency. Because of the constant frequency, there is a metal which is being kept over here. This metal starts tapping like this, and the tape that you have over here is run below this tapping mission. Okay, it's run below this tapping mission. So as you pull it across, what you can see is you put a carbon sheet here, put a carbon sheet over here, okay, below this, and then as it taps, it records a dot over there on the paper, and then it taps 2 times, 3 times, 4 times, and so on. It keeps on putting a dots over there. If the tape is being pulled uniformly, then you get something like this. That means the dots are equispaced. What is this called as? Uniform velocity. Okay, here also there is a uniform velocity. But if the tape, okay, moves faster, then what can happen? See, initially dots may be closer, and after that, you see, the distance between the 2 dots will now change. Let me change my pen to indicate that. Right. Okay. So distance between 2 dots. See, this distance here is different from this distance, different from this distance over here, right? So as a result of this, what can you say here? As the distance increases, okay, is it an acceleration or deceleration? Larger distance, same time interval, okay, it taps at the same time interval. So therefore, so S increases, T is same. So therefore, now what you can see, the velocity is increasing. The velocity at this instant is, let us say, V1, is this instant is V2, then V2 will definitely be larger than V1, and as a result of it, the acceleration will increase. Now here what's happening? It is decelerating. Okay, that's what we can understand, okay, by looking at the ticker time apparatus. So what is it we have tried to do? We have tried to get the value of acceleration using the distances. Now what's your variable? Your variable will not be acceleration. Acceleration you are going to calculate, right? Your variable is this distance over here. Okay, this distance traveled by the object as it is moving. So therefore, now what was our RQ? How does the variable affect the acceleration of a moving object? So I can now write this as, let me write it over here itself. I can say, how does the variable. I do not know what variable I'm going to take. Okay, I have not defined the apparatus so far. I do not know this, but I am interested only in the acceleration part. How does the variable affect the distance between the spots? You can write it with respect to emission, or if you do not want to be very specific over here, you can say affect the distance traveled by the object. You can put this also, no worries. You can do it like this also. Okay, we have got one idea. We have got that we come to know that we can measure the acceleration, or maybe we can change the acceleration variable to distance. That's what you can know, but we still do not know what is this variable here that we need to look into. Okay, now let us look at the next one. How do you measure using a watch and measuring tape? Okay, watch and measure. What is that you do? You take an object, for example. Say, why only taking an object, dropping it, why putting it across an inclined plane? I can take an object from the top and drop it from there, right? Okay, and I can do it from various heights and it can start falling down. Okay, when it starts falling down, instead of saying length of the plane, we can say distance traveled by the object, something like this. See, I have, let me change my pen to make it more clearer. Right, okay, I have something like, I consider this one here, a cliff, for example, some tall object, and from here I drop. Okay, and then I find out what is the time taken by the object to start from here and to reach it. Okay, I get this time. The length is already known to me, so from here I can easily calculate L is equal to ut plus half at square, and then might be I can say as I vary the length, the time taken can also change, right? My RQ changes over here. Okay, so I have got the variable, I have got the acceleration to be replaced by length. Wow, this works well for me, right? I can think about it. Okay, why you want to do, why you do not want to do, you can discuss about all these things. I'm not going to advise you to do this experiment or any other experiment and so on. You can discuss with your teachers and get to know whether this could be a feasible one or non-feasible one. Okay, what are the advantages, disadvantages? We also need to look at whether these kinds of experiments have been performed by somebody else. Tomorrow, after you finish your experiment, turn it in, okay, and you see the plagiarism report, if you get the same thing, of no use, right? Okay, so that also you need to look into it, right? Let me go on to the next idea. The next idea is about one more tool. Okay, what I have discussed so far is about what are the different types of tools which you can use. Video analysis software. This is software known as a tracker. Okay, you can go to Google and download this one. So what it does is that whenever there is a moving object, you can now calibrate the length of it or whatever you are going to do, and then you can fix a particular spot into it. First, you can take a video. Okay, whatever is happening, you drop an object, you do whatever you want, you drop an object, you get the video of it, feed it to this one, and then track a point on the object. And then what you do is you say calibrate it or determine, okay, what is the speed, what is the distance. You can do all these things. Okay, and then now as the object starts moving, it calibrates, it finds out, okay, what could be the distance, what could be the velocity, and so on. Some examples are shown over here. For example, in biology, you can do this in biology also. Okay, like a rat is moving on in various direction. You can find out what is the distance moved by it. You can track the position of the rat's tail or maybe rat's head or whatever you want to do. Now here, as you see, the same thing. See, there's a viscous fluid over here. There's an object which is dropping from here. As the object starts flowing, you can see the dots are all of equally spaced. So what does it tell you? It's almost going with a uniform velocity. Okay, and then you can also get a graph also, right? That's a wonderful thing. Then look at this over here. What is this experiment? This experiment is your double slit experiment, wherein you have water surface, you have 2 points, you just tap on top of it and then you get ripples over here. Okay, how does the ripple starts moving? See, the ripples are started moving. Either it is moving with an uniform speed, whether it's moving with uniform acceleration. You can get this also. You can plot a graph of this, right? So this also been given by the software. See, look at this one here. See, all this, what you do is you take a video of it. You take a video of this and then perform the video analysis software. The next one is, so look at this over here. So there's a pendulum which is moving here and there. So what did you do? You took the spot of the pendulum's bob and then you fix this and then you find out, okay, how is the bob moving across? And then you found out, okay, what is the distance traveled or maybe the acceleration. So you are able to plot a graph like this. See, wonderful things, you know. So what you think that you will not be able to design because non-availability of a apparatus. Okay, you can easily do it using your camera, right? Using a camera or using your phone. Your phone itself is a lab for you. Okay, in further next slide I'll show you what other things you can do using your phone. Okay, so you can do a lot of things over here. Next, Phyphox. This is a free app available in your phone. Okay, and what you can do is you can conduct a large number of experiments using this. Okay, every sensor is available. Most of sensors are available, so you can use an accelerometer there. Okay, what is an accelerometer? It finds out the acceleration directly. So far, what is that we are worried about? We are worried about we cannot use acceleration at all. We cannot find acceleration. You see, you can easily find out. So this gives you a plot of the frequency of how the acceleration changes with time. It also tells you about how with respect to time, what are the different types of acceleration. You can have an x acceleration, y acceleration, z acceleration. You can take a mobile phone, okay, and then put it onto your swing and make it to oscillate like this. As it starts oscillating, you can find out what is the acceleration here, right? But the problem there is that you will get x, y, and z. You need to decide which one to use that one, and finally you can get a list of this one. Not only the diagram, you can collect all this using an Excel sheet in the CSV format and then try to analyze it. Okay, you can do wonders using these kinds of apparatus. Okay, so now somewhere we have come to a conclusion saying that we can do this. The better thing what I thought was that, okay, so maybe I can change the angle, easier for me to do it. Okay, so therefore if I have an incline, like this, I can change this angle. Theta can be changed. How do I change the angle? If I say, for example, I can take books, I can lift it across, I can put a protractor, I can change the angle, and I can take an object over here, and as I change the angle, it starts moving. Length also I'll fix it. The time taken by the object to start from here and to reach here, okay, I can calculate. So therefore the variable here is theta. Then the dependent variable which I am going to measure is nothing but time taken. Well, we've got both of them. We have got this as your independent variable, this as your dependent variable. So as a result of it, now I can put across a sample hypothesis. What is it? If the incline angle increases, the acceleration of the object will increase. Okay, so you need not write the acceleration over here. Instead of this, you can say then the time taken by the object to reach the end of the incline. Make it very specific. When you come to a hypothesis, you should be very, very specific. Okay, increases provided. What is it provided? You can say provided friction between the surfaces remain a constant. You put all this now. Okay, now let me move on to the next one. Now what is that we are going to do? We are going to take an object, slide. Of course, here it is rolling. Okay, it's not roll, it should actually slide over here. And then find out, okay, what is that you are going to change over here and so on. Just a moment. Okay, so this is what you are going to do. You are going to find out what is the independent. We have defined already. Dependent is acceleration of the object, and maybe the time taken. Okay, and then the controlled variables are mass of the object. You are not going to change the mass. You are not going to change the surface type. Everything remains the same. So it's also fine. Any other possible conditions you have, you can mention all this, right? But on all this now. Okay, we have come until we have finished your section A, that is your criterion A. We have come to criterion B also. Okay, sorry, criterion A only, not even criterion B. We are looking at criterion A, the relevant math concepts. Okay, many times we get stuck here. Okay, most of students get stuck here, understanding about why, how to do with it, and so on. So you need to look at the physics behind it. Okay, without understanding the physics behind it, don't do this. Okay, so you cannot just do an experiment, get some data. So you will get less marks. That's what it is. So relevant math concepts. What is that? It is on what factors does acceleration depend upon. Don't write anything else over there. Okay, write something which is relevant. Okay, change in velocity by time taken. You can use this equation. Is it useful here? No, it's not useful over here. So you can find out that, okay, the force that is acting over here is g sine theta. So from here you can find out the acceleration, and as theta changes, the value of sine theta changes, and thus the value of g sine theta also changes. And then, okay, you can plot the graphs. You can think how do the formula connect to the variables. Always remember the formula that you write should be connecting to the variables. If it is not connecting to the variables, you are not given the relevant map. Don't start explaining all the kinematics over there. Okay, kinematics is not necessary for an examiner. Examiner knows better kinematics than you, so don't mention all those things. Right, next, type of apparatus. In our labs, we have a friction apparatus. If you have this, you can use this one here. If you don't have it, you can just take a plane like this over here and put across something like this, and okay, you can elevate it across. Or you can use this simple and simplest of things. If nothing is available over here, you can just take a wooden plank. You can put some papers or books or something, and you can lift it across. Okay, only thing is you need to measure. You need to measure what is the value of the theta here. That's it. If you measure it, it's fine. Okay. Next, after this, then what do you need over here? You need a ramp, you need a timer, you need a measuring tool, you can use a mobile, you can use whatever you want. And what else do you need to collect the data reliably? You need to put a tabular column appropriately. You should do all this, see to it that there are no environmental influences. There's nothing like, okay, people come and disturb you. So all these things should not be there. Okay, that you have to be very careful. Then next, data collection table. So data collection table, okay, so you put across what is that you put into. If you are doing something like dropping an object over there, so use a height, time, and see to it that you put the units properly. Use the uncertainties properly. Okay, or if you are using something like angle of the incline, use this one over here. Okay, what other data you want to record, mention everything over here. And what are the comments that you put across over here while you do it? See, this is not something which you are directly going to put in your report. Okay, as much as possible when you start collecting data, collect everything that is possible. Okay, so put the comments, put, okay, what are the comments that you did it correctly, you got it steady, and if there's a minus fluctuations, put it across over here. So mention everything. Okay, it should be something like a journey. Okay, your experiment should not be something like, okay, I need to do an experiment. It's not an experiment over here. Okay, if it was an experiment, I could have told you, okay, there are several books available. You can go to web, you can search for several experiments based online, and you can do it. This is a passion experiment. A passion experiment is something like you do it because you liked it, you wanted an answer. Okay, and hence you want to do it, and you have done this. Okay, so this is what you are doing here. Now let me move on to the next slide. Now finally, evaluation. Okay, Criterion C. You need to discuss about the sources of uncertainty and error. Why do you get something as uncertainty? What is the error in this? You need to ponder on to it. What are the limitations of your method? Okay, say for example, when you dropped an object from a certain height, it started moving along an incline. Then what was the limitations of this method? So when you started your timer, okay, so how did you start? You started your timer based on your timer in your hand, and you started it. So by the time you started, the object would have moved a little bit because you have a human error, right? So that is something like a limitation of the method. And second limitation could be something like as the object started moving, okay, let us say you are using a wooden plank. Okay, so in the wooden plank, there could be small potholes there. Okay, the object would have slowed down something, moved faster and so on, right? The friction would be unpredictable. Maybe even if you use a glass also, the glass may be uneven thickness. This could also be there. There could be dust particles into it, right? So that can also be there. The angle that you measure over there may not be the same. Okay, you would have made a mistake in your angle. So many things that you can think of. Think of it, okay, and try to put it across. And then suggestions for improvement. How do you improve this? Okay, what is that you want to do or improve it? For example, when you are using an inclined plane, what you can do is you can put a photo gate. Put one photo gate here, put another photo gate over here, and then try to do the experiment. So human errors would be completely eliminated. You can do that one here. Now, when you say and you're making an object move across in a plank, what you can do is you could have substituted this with a glass plank and put something like an oil, smear some oil on top of it, use a glass prism on top of it, drop it onto it, so that the friction would be completely even, right? Okay, uniformly it would have gone across. So this could be an improvement. Strength of your conclusion. So what is it you conclude? Okay, how does the acceleration depend on it? You need to evaluate based on your math, based on your theory, whatever you have got, you need to put it across. Okay, and you also need to look at, okay, is there a random error? When you want to look at a random error, what is that you need to do? You need to do it something like 5 or 7 trials, okay, per observation. 5 trials is fine, 7 would be too much. Okay, so if you are doing some experiment related to it, then you can do it. Okay, 1 observation, 5 trials, okay, and look at, okay, do an outlier analysis. Okay, which of these are outliers, which of them are non-outliers? Consider those only, okay, which is systematic one, okay, and consider is there a role of any systematic error there. Put across everything. Okay, so what all you can do it, just do that. right? And then next, finally, come to a conclusion. In conclusion, what is that you need to put across? You need to write a clear and direct answer to the RQ. Okay, does your experiment satisfy your RQ, or does it go somewhere else? So whether you get a positive result or a negative result, mention it. Okay, if you get a negative result, do not think, hey, I made a mistake. You not made a mistake. You can get a negative result. I have several students reports with me wherein they have got a negative result but still got higher marks. The reason is because IB only looks at how you are substantiating it, how you are justifying your negative result. Okay, let us say you are doing an experiment related to the value of G, acceleration due to gravity 9.8. You should get. You did not get 9.8. You got 9.1. Okay, does it mean that you are in a different planet? No, you are on the same planet only. But then you can substitute. You can just justify saying that why did you get it? What went wrong, right? So if you had done it in this way, then probably you would have got a correct. So mention that. Interpretation of the process data, you need to put across the graphs. Okay, so using the graphs, first you do with the raw variables, and after that you do your process variables and try to linearize the curve, try to get the line of best fit. Okay, find out, okay, what is the intercept. Say for example, if you get an intercept like this, what does this, if you get a curve like this, straight line like this, what does this line actually indicate? What does this indicate? Okay, what does the slope indicate? What is the intercept? Usually I tell you, whenever you are talking about a graph, okay, there are 4 parameters which are very essential. The first parameter is slope. You could have seen this in many of my lectures whenever I'm doing something on the past paper questions, which you can see from my website. So slope, the second one is your intercept, third one is your area, the fourth one is your pixel, right? So any of this could be useful. In some cases, area might be useful. Some of them area may not be useful, but look into it. Okay. And then reference to associated uncertainties. Why do you get a larger uncertainty somewhere? Why do you get a smaller uncertainty somewhere? Is there a propagation of uncertainty coming into it, right? So you need to look into all these things. Link to scientific theory. Okay. So what is the accepted model? A equal to G sin theta. Okay. So see to it that, okay, it is following that one. Okay. What is the deviation seen there? And if there is a deviation, why do you get a deviation? Put it across all this. Then source citation that is traceable. There should be some source citation. Don't put something like, I refer to Soko's book. I refer to Wikipedia. Okay, Soko's you can put it across, but don't put Wikipedia. Wikipedia articles are not considered. Okay, do a research. See, your IA and EEs are given to you not to see how you conduct the experiment. It is only to see to it that, like, how your critical thinking skills and research skills have been improved. IB is one such curriculum where we focus more on these kinds of skills and not just about, okay, doing something which is there in your manual and then writing it across. We're not interested in whether you got the value of G equal to 9.8 or not. Somebody already has established it, right? So we already got the value. So we are not looking into your research and all. We are just looking at what is your journey. Okay, how did you look into it? Do you really know how to cite an article? Do you know how to search for articles? Which articles are very similar to it? Have you taken the proper articles over here? So these kinds of things are very important. Statement about how consistent the data is with scientific context. Okay, so is there a systematic error? Okay, or if there's a random error influence your data, and is it that, okay, every time you are getting the same kind of repetition? So what is it you are getting? You would have got something like errors like this, right? Error bars like this. Okay, so how is it being distributed? So all these things you can talk over here. Okay, so with this, I think yes. Okay, so these are some of the important things that one needs to know while conducting an experiment. Of course, when I say this one, okay, it is not that, okay, I looked into this video, I immediately start doing it. Not so easy. Okay, it takes some time. Okay, I have seen for the past 5 years, okay, as I'm teaching to IB, and I was also as a part of the research examiners. Okay, so I have seen how students struggle while you get a problem, when you start with the problem or to proceed with the problem. Okay, every part of it. See, it's not only my video. There are several videos on the web, okay, which have done this. But still students have a difficulty. So what I have thought of this was that I take up similar problems like this. I take up the live problems. Look at all these sections. Refer to something like 4 to 5 videos like this. Okay, so you get a general idea. The first major problem is that it lies in somewhere over here. Where does it lie? It lies here. Okay, defining an RQ. When you start defining an RQ and you have got it correctly, then definitely the rest of them will definitely become very, very easy. So somewhere defining an RQ becomes very, very important. Once you define an RQ and you have defined the variables properly, when you go until the variables, things becomes very, very easy. Okay. So first nearly 3 months goes only in understanding what you need. Okay. So with this, I think I have come to an end to this video, and let me see you once again in tomorrow's videos to understand about how do you define RQs, or what is a different RQ. I'll take up a different RQ and start with it. Okay. If you really like this video, do like, share, and subscribe to my channel so that you can get more updates. So every time I start with something, recently I started with AI tools. I did some 12 or 13 tools, and then I thought it was okay. So to some extent, okay, but still, you need to conduct some experiments. Some students suggested to me in my WhatsApp group saying that, okay, so we need something like this. Okay, so understanding of IA would be very important. So I just looked into this. Okay, thank you for being with me. Thank you once again.